How to find shells and valence electrons. Number 1, in the periodic table, each row is called a period. You can see a row goes across from left to right, and it's highlighted here in yellow. Number 2, the elements in each period have the same number of electron orbitals or shells. So I've circled this first one, which is potassium, and here is a drawing of a model with the nucleus here in the middle and the orbitals on the outside. So you can see there's 1, 2, 3, 4 rings or orbitals. Each orbital has electrons. So these electrons they're represented by dots, and they go around the outside of the nucleus. 3. Each column in the periodic table is called a group. So groups go up and down its columns, and you can see there are many, many groups. So 18 altogether. This one has a section cut out, so it looks like there's 17 showing. Each of the elements in the same group have the same number of electrons in their outer shells. So here is calcium, which is right next to potassium. So it also has 4 orbitals of electrons, 1, 2, 3, 4. And it has 2 electrons, 1, 2, in its outer shell or orbital. Number 5, the electrons in the outer shell are called valence electrons. So here's calcium again, and it's a little bit different drawing, but you can still see the 2 valence electrons, the nucleus in the middle, and then the first, second, third, and fourth orbital shells for all of the electrons going around the outside. Number 6, the atomic number, which is always either at the very top in the middle or in the corner, tells you the number of total electrons or total protons. So in this case, if we're looking for the valence electrons, might be 2, but calcium has 20 total electrons, and it does have 20 protons in the middle of it in the nucleus. 7, to find valence electrons, we have to number the periodic table like this. So even though if we look back at an old periodic table, you see all these numbers and there's a whole bunch of groups. We're going to renumber these groups so that the first group is 1, the second group is 2, and then all of these ones in this, where the sink, where it sinks down, these are all also 2. And when you come back up, 3, 4, 5, 6, 7, 8. So you're going to cross 1, 2, skip 3, 4, 5, 6, 7, 8, and then all of these are 2. This helium sticking up here is 2, and then 8 is from neon all the way down. These red numbers tell you the number of valence electrons in each group, the number of electrons in the outer shell. So here are some examples of valence electrons. Once you have these numbers written in on your periodic table, if you look for Ti, you just go up to that number that you wrote. It has 3 valence electrons, 3 electrons in its outer orbital. Be has 2, and P has 5. Number 9, the purple arrows right here show the trend of reactivity caused by valence electrons and the number of electron shells of elements. So if we look here at the left and we're going down the period, so down the period, reactivity increases down the group as the number of electron shells increase. So more rings around the nucleus, more reactivity. Then now at the bottom, we have to read this arrow from right to left, so backwards from the way that you normally read the page. Anywhere on this periodic table, whether you're in the first group, whether you're in the first period, you're the first period or the last period, when you go from right to left, reactivity increases in the period from right to left as the number of valence electrons decrease. So these guys over here have more. They've got 8, 7, 6 valence electrons. These guys only have 1 or 2, so they're more reactive over here. What do we mean by reactive? Well, reactivity is an element's ability to combine with other elements, and it's all determined by this outer orbital. If there are a lot of electrons in there, it'll pick one up from another atom. In this case, sodium is a very reactive metal because it only has one little valence electron here, and it's really quick to give it away so that it'll have this outer shell full. And I'm going to show you what I mean by this little metal. See how small this is? He's got tweezers. It's a very, very small piece of metal. Now wait for it. This is pure sodium. Sodium not in table salt. The sodium without the chlorine in your table salt. Now wait for it. Wait for it. You saw how small that is. Wait for the fireworks. It's going to, there it goes. That's what I mean by reactivity.